Okay, once again, I'm Roy Wong here. So I will be the HCMP WLAN trainer. So this is the WLAN radio management, topic number 2. Know the concept of the WLAN radio management, common use WLAN radio management technologies, okay, and also explain the implementation principle of WLAN radio management and configuration WLAN radio management. Introduction to the WLAN radio management. So this is the RM, also stand for radio resource management. So what's the function over here? Automatically check the surrounding radio environment. So they can able to using those for the prod request and the response frame to detect the surrounding interference. Okay, dynamically adjust the radio resource such as the channels and transmit power. So they can able to detect whether they have the core channel overlapping the interference or the adjacent channel overlapping. Intelligence balance access user. They can perform the load balancing for the access user. Okay, preferentially distribute the 5 gigahertz frequency band capable terminals to the 5 gigahertz frequency band. And the purpose over here, mitigate radio signal interference. They try to reduce the interference on the surrounding. Maintains the optimal radio resource status and can able to provide a high quality service for the wireless network user. So this is like some sort of the QoS. So this is the feature for the RM. So we'll start from the radio calibration. Okay, content number 2, radio calibration. So as you can see from the picture over here, before and after. So what I mentioned over here, the radio calibration include the dynamic channel adjustment and also the power adjustment. Then for the radio calibration mode, include the global radio calibration or the partial radio calibration. So these two you can select either one. So as you can see the before, right here they have channel number 1, channel number 6. Okay, 2 AP using the same channel number 6. So after we enable the calibration, so you do some calculation based on all the probe requests they're going to send out. They can able to detect all the interference from the different channel. So right now, the AP on the top here, the right on the top, previously they're actually using a channel number 6, but after detect the surrounding, they have another AP which is running the channel number 1 and channel number 6. So they'll know this is not allowed to using a channel number 6 because when using a channel number 6, you'll cause the core channel overlapping. So that's why they decided to change the channel into 11. So you can see after the channel is already become 11 here. So and this one also happened to the new ender AP. Okay, when the new ender AP they detect the surrounding here, they have the channel 11 and the 6 just beside it. So you would use channel number 1 only. So this is a dynamic channel adjustment. To ensure that each AP in the allocated and optimal channel to minimize or avoid the adjacent channel or the core channel interference. So before the channel adjustment, you can see over here they have total of 4 AP, and 4 AP you're going to using some of the random channel. So maybe the first one you're going to use the channel number 1. Okay, on the right here on the top, the channel number 6. So right here they have 2 AP using the channel number 6. So they cause the interference on the overlapping area here. So after we're going to enable the radio calibration, so they can able to help you to do some calculation you based on the interference in the network over here. So do the auto adjust for all the channel, and this auto adjust is not only based on one AP. There can be the multiple AP as long as they belong to the same group. So right here, the AP at the below, the left on and also the right, you'll notice they already changed the channel. So the channel number 6 and channel number 11. So to prevent the interference in between. So it's not only happening to the channel and the power, they also can do the auto adjustment. So how they can able to detect it? So the answer here is very simple. When all the AP they trying to send out those of the port request, okay, to the surrounding, you're going to broadcast all those frames to the A. So when the AP1 try to send a port request to the surrounding, so no one can able to receive. So this one is one of the BSA area that coverage by the AP1. Then the AP number 2 over here, they also have its own BSA area. Okay, same to 3 and also the 4. So right here you can see before the AP4 go offline, so everyone have the same the BSA coverage area. Okay, almost the same. But right here the AP4 is slightly smaller, but it doesn't matter. So when the AP4 go offline, do you notice the AP3, the BSA increase the coverage area. So they actually can automatically detect it when they know the surrounding one of the AP when they go down. So when they detect one of the AP is really going down, then I can adjust my power, the strength of the coverage area become bigger, so they may have a wider coverage in this area. The AC first, you're going to send the AP a request. You're going to ask the AP to start the neighbor probing. So when the AP receives it, you're going to follow its order and send the probe request and try to scan the surrounding, see whether they got how many interference in between. Then once they done everything ready, you're going to send the report back to the AC. So AC will base on the report and do the calculation. So right now, what all the AP can able to do now. So like example, right now this AP, are you going to change the channel now or you're going to adjust your power level? Okay, so this one will be based, everything will based on the AC here. Okay, allocated the channel and the power to the AP based on the algorithm and deliver a calibration result to the AP when they have any chance and when the AC need the AP to do the changing. So you're going to deliver the calibration result to the AP. The neighbor probe. So the purpose here is to collect the information about the surrounding authorized AP, include the unauthorized AP and also the non-Wi-Fi device. So you can see from here, one of the AP at the middle, they try to send a probe request to every AP surrounding here. It doesn't care, it doesn't care what is the channel they use by all the AP here. So they try to keep sending a probe request to get the information because they want to know in my surrounding here, they actually have how many the unauthorized AP, authorized AP, or the non-Wi-Fi device is accessed beside my current AP. Then below here, for the neighbor probe mode, they have active probe and also the passive, two different types. The AC can display neighbor relationship between the APs and the neighbor device. Okay, include all the device. So as you can see over here, this is our current AP connected to the AC. So you're going to send all the probe requests to try to detect all the wireless device over here. They can check every single device, even you belong to the Wi-Fi device or not. So you're going to check not only the access device, they also can tell what is the current signal strength in between your AP and the non-Wi-Fi device or maybe the AP. So they can get all those information here. So let's look at the calibration algorithm. So we have a few steps. Starting, you're going to randomly group the AP. Implement the radio calibration on each AP group to obtain the optimal channel configuration of each group as well as the channel configuration of APs to which channel are distributed. using an SN over here to do the record. So calculate the total interference that the AP which channel SN is to be will receive from other AP. So let's go from here. So this is the calculation. Is the interference of the current channel, okay, SN is smaller than the interference of the last channel SN. So the SN over here, they have the meaning. Okay, you can see the SN indicate the channel configuration of all the AP in the current interaction. Okay, this one is for the last interaction. So right here, if they're going to check when the current channel is smaller than the interference, when there's no, then they're going to using the original previous the SN, the channel. When yes, they go for the new channel. They're not going to use the current channel because they detect it. They actually have the interference right now. When they have a very strong interference, there's no point for me to stay at the same channel. So I have to change my channel to another one. So replace the channel S-1. That means my previous channel. So with the new channel SN. So the power calibration algorithm involves the following step. You're going to calculate the upper and also the lower neighbor interference threshold. Okay, we detect the signal also. Okay, check whether the neighbor interference is larger than the upper threshold or smaller the lower threshold. So when the neighbor interference is low threshold, so that means actually in between my neighbor and me, they have not much interference. So that means I'm allowed to increase my transmit power. When the neighbor interference is upper the threshold, so that means they right now me and my neighbor they have the very the large interference happening in this area. So that's why I have to reduce the transmit power, okay, to smaller down the interference here. So here's a key point. So we need to know what's the default for all the radio calibration here by default. The partial radio calibration is enabled. So normally they're using the partial by default. Okay, the global you can see from here is disabled. And the radio calibration period is 60 minutes. So mean going to do it every hour. Radio calibration is implemented based on the AP group. So that's the reason why we need to create a group. Then the next one, the radio calibration on the WDS or the mesh link might disconnect the link. So normally it's not recommended in do it on the WDS or the mesh network because once they're running the what we call the calibration in the WDS, because for what we know the WDS must using the same channel in order to form the point-to-point connection, or maybe when we for the calibration because they want to reduce the interference between the two different AP, and the WDS is required the two AP to work. So when the calibration is already enabled, and right now you're running the WDS, what will happen? So the AP number 1 and AP number 2 are still dot. Right now they actually will actually are facing the interference right now. So they're going to reduce the power level of the radio. So when they're trying to reduce the power level, then they'll make the WDS fail to forming. Okay, so this is some of the example from over here. Okay, here is some roadmap for us to do the configuration. Configure automatic channel selection and automatic transmit power selection. If you're going to set everything to the fixed, then the radio calibration might not able to work. So that's why we need to set it to the automatic. Okay, configure the calibration mode. What kind of calibration that you want to use here? Okay, configure the neighbor probe and apply the radio calibration to APs or based on the AP group and apply. So what we're going to do here, we have to go inside the WLAN view using a command called RRM profile. Just give a name for this RRM profile we do. So from here, we use the command undo calibration auto channel select disable because for most of the WLAN device here, by default, the calibration is not enabled by default. So if you want to turn it on, okay, we're using the command called undo here. So we just follow the CRI here. You can see using the code undo calibrate auto channel select disable. So this means now I'm going to enable this feature. Okay, and also same to the auto transit power. Okay, by default it's already disabled. So when we want to enable, we use the undo command to make up. Then the follow-on is trying to bind the area profile into the 2G radio profile. So we just using a command radio 2G profile. Okay, just give a name here. Okay, any name. Then we go to the inside this 2G profile here. We're using the RM profile POC that we create. Like example right now, I name it as WLAN NAC. So I just go in here, use RM profile WLAN NAC. That's all. That means I already bind this profile into my radio 2G profile. There's 3 radio calibration mode. So we have to select which mode that you want to use. By default, they're actually running the manual. Okay, so here we have the option for the automatic and also the schedule. So right here, on the first step, they actually try to show you using the calibration mode set to the auto. So it's just using a command called calibrate, enable, and then followed by auto. So this is a way how to enable the auto. When you want to use a schedule, so you have to type in the calibrate, enable, schedule, followed by the time, and then the time. Okay, how long they're going to calibrate it again. Okay, then the next one is configure the scan function for the radio calibration. So we already configure the mode of the calibration, what we need to do that. So the next one will be the air scan. So first on the WLAN, we're using the air scan profile and then give the name for this air scan. So over there, we're using the country channel. Okay, scan channel set. Just put the country channel over here that you want to scan. Okay, and the channel period. So you're going to scan for how long? Okay, the AD over here actually is using the millisecond to do the calculation. All right, so by default, they actually 60 millisecond. And the scan interval. Okay, this one also using the millisecond to do the calculation. Okay, after we done all those configuration, then the next one, don't forget to create the AP group. Okay, AP group, give the name. So right here, I will use the regulatory domain profile. I give the name here. We just give the name, domain name, domain 1. So after that, try to bind just on the profile that we create previously, like the radio 2G profile. Okay, the name just now I using the radio 2G.